A probability distribution is a tabular or graphical representation of the probabilities of each of the outcomes of an experiment. So a probability distribution, for example, here's the rolling of 2 die. So the probability distribution for the sum of 2 dice, you have all your possible outcomes here, and then you have the probability associated with each outcome. So this is what is called a probability distribution. Uh, distribution. Okay, so you can have a graphical presentation of a probability distribution, but I tend not to put test questions on this. But just so you're aware, you could have probability along the left-hand side and the different sums along the bottom, and 1 over 36 is a little less than 0.05, etc., etc. And you can show the probabilities that way. Okay, but this is, if I ask you for a probability distribution on the test, then I'll be asking for something where you show all the outcomes and then list the probabilities. So, just a few definitions. What is a random variable? Okay, so a random variable is a variable whose value is determined by the outcomes of an experiment. Okay, so, right? Or another way, a random variable also is a variable that can have any set of different values. Okay, so for example, the random variable, the sum of 2 dice, is a set of different values, and the probability distribution shows the values as well as the probabilities associated with each value. Okay, so in example 1, the random variable x was the sum of the 2 dice. Okay, let's look at a few examples just to make sure you understand it. Does anybody still need that page? Well, we won't wait for you, but I'll let you look at it later, okay? Okay. Define the appropriate random variables for the following experiments and indicate the values that the random variables may take. A task force committee is to be selected, and it is important that there is a fair representation of males on the committee. So, a fair representation of males on the committee, then the random variable x is the number of males on the committee. Okay, and what values may it take on? Well, depending on the size of the committee, it goes 0, 1, 2, 3, all the way up. Then it depends on the size of the committee. They didn't tell us the size of the committee. 3 dice are rolled, and the sum on the 3 dice is to move a piece in the game. Okay, so the random variable x is the sum on the 3 dice. And the value those can take on are 3, 4, 5, all the way up to 3 times 16 is 18. So all the random variables in this unit are outcomes that can be assigned integral values. In other words, this whole unit is dedicated to discrete random variables. How many people in the car? How many people on the committee? Etc., etc. It's either 0, 1, 2, or 3. And associated with each random variable will be a probability denoted by this. Okay, so let's look at a simple example. Determine the probability distribution for the tossing of a coin. All right. Let the random variable x be take the value 0 if a head is tossed, because we need numbers, right? And 1 if a tail is tossed. You could have picked 5 and 10, whatever. Probability x equals 0 is equal to probability of 0, which is 1/2. Probability x equals 1 equals, another way of writing it, right, is equal to 1/2. So here's our toss, x, and our probability. We can show it in a table, or we can show it as a graph. And then they do these stick drawings, which I always found interesting. So this is as a graph, and this is as a table. You can show a probability distribution in either one of those two ways. Okay. The expected value is like an average. Okay, on average, what can you expect to obtain? So the expected value is the quantity you can expect to obtain when the experiment is performed. To calculate the expected value, we use the definition. We won't worry about that little x there. The sum of x px. It reminds me most of a weighted mean, but instead of weights multiplying each outcome by its weight, we multiply each outcome by its probability. So let's do an example. A game is defined by the rules that 2 dice are rolled, and the player, we lost the P on player, wins varying amounts depending on the sum of the 2 dice according to the following table. Okay. So this is what you can win depending on each roll. The cost to play the game is $7.50. What can the player expect to win by playing this game? What would be a fair value to pay to play this game? Okay, so let's look at this. Let's do a table here. We have our winnings. So we're really going to calculate our expected win. We want his expected win. So the possible winnings are, the lowest is 5, the largest is 10. 5, 6, 7, 8, 9, 10. Okay. What sum do you have to get to, well, you can either get a sum of, to win $5, you need a sum of 7. And there, you can only get it with a sum of 7. But to win $6, you can either go sum of 6 or sum of 8. And for $7, it's sum of 5 or sum of 9. And for $8, it's sum of 4 or sum of 10. And for $9, it's sum of 3 or sum of 11. And for $2, for $10, it's sum of 2 or 12. So now we have to calculate the probability of x. So maybe we better draw some lines here, or it's going to be hard to follow. So maybe should we do a die chart? Okay, so the probability of rolling a sum of 7 is 1, 2, 3, 4, 5, 6, 6 out of 36. And a 6 or a 8, which you can reduce it to 1 over 6. 6 or a 8 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 5 over 18. 5 or a 9. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 2 over 9. 4 and 10. 6 over 36 equals 1 over 6. 3 and 11. 1, 2, 3, 4. 4 over 36 equals 1 over 9. 2 or 12 is 2 over 36 equals 1 over 18. What should all these add up to? What should the sum of the probabilities add up to? Any ideas? 1, right? 16, 24, 30, 34, 36. 36 out of 36 equals 1. Now we can calculate the expected value. We're going to calculate x times the probability of x. So $5 times 6 over 36 is 30 over 36. $6 times 5, well, I'm gonna stick with the 36, then it's easier to add then. That's going to be 60 over 36. $7 times 8 is going to be 56 over 36. 48 over 36. 36 over 36. And 20 over 36. So our expected value, our sum of x, px, is equal to 250 over 36, and that's approximately $6.94. So our answer to part A, on average, you can expect to win $6.94. B, right? What would be a fair, now see how it costs $7.50 to play? So this is not a fair game because you can expect to lose $7.50 minus 6.94, 56 cents per game. So what do you think is a fair price for this game? 56 cents. So I'm going to have to, right? A fair price for this game is $6.94. That would be $6. So it has to be fair to the player, and it has to be fair to the organizer of the game. It has to be fair to both in order for it to be fair. Can I explain anything better? So you calculate on average what you expect to win. In this case it was $6.94. That's lower than the price you pay to play the game, so it's not a fair game. Not fair, not fair, not fair. We'll do one more example. Good? Okay. A committee of 4 people is to be chosen randomly from 4 males and 6 females. What is the expected number of females on the committee? Okay. So let the random variable x be the number of females on the committee. Okay. So we have, well, it's a committee of 4 people, so the number of females, you could have 0 females, 1 female, 2 females, 3 females, or 4 females, right? What's the what's the probability of 0 females? Well, out of the 6 females, we choose 0, and out of the 4 males, we choose 4. And that's divided by the number in our sample space, which is 10, choose 4. and that is equal to 1 over 210. So now we can go 0 times 1 over 210 is 0. Okay, now for what's the probability of the number of, what's the probability of having one female on the committee? Well, we're going to go 6 choose 1, 4 choose 3. Now we only need 3 males. 10 choose 4, and that is equal to 24 over 210. And when we go xpx, 1 times 24 over 210 is 24 over 210. So again, 6 choose 2, 4 choose 3, all over 10 choose 4, and that will equal 90 over 2. 4 choose 2, you're absolutely right. 4 choose 2. Thank you. And that's 90 over 210. And that, so 2 times 90. I hope, yeah, my eye jumped to the 3 row. Okay, so 2 times 90 is 180 over 210. 6 choose 3, 4 choose 1, all over 10 choose 4, and that works out to be 80 over 210. And 3 times 80 is 240 over 210. So 6 choose 4, 4 choose 0 over 10 choose 4, and that equals 15 over 210, and 4 times 15 is 60 over 210. So the sum of all our probabilities should equal 25, 115, 195, 200, 210 over 210, and that equals 1, right? And when we do the sum of xpx, we get 2.4. So you wonder, can you have an average of 2.4 females on a committee? Yeah, because it's an average. Two, that should be 60 over 210. 300, 480, 504. Yeah, 504. The sum is 504 over 210, and that equals 2.4. So, therefore, you write it like this. The expected value of x is equal to 2.4, right? That's the symbolism you can use. And on average, we can expect 2.4 females on a committee. Okay? What I'm going to do is input your marks, and when I'm done inputting, I can give you your test back.